Welcome to a brand new math video. In this video, we are going to be finding the prime factorization of a number. Evidence-wise, you're going to find the factors of a number, you're going to understand what a prime number is if you don't already, and then we're going to actually write our prime factorizations. Our learning experience is there. You can read it over if you'd like. So what is a prime number? Prime number is a number whose factors are just 1 in itself. There's nothing that you can multiply together to give you that number, no whole numbers at least, other than 1 and itself. So some examples: 1 is a prime number because the only thing you can multiply together to get 1 is 1 and itself, 1. 2 is a prime number because the only two numbers you can multiply together to get 2 are 1 and 2. 3 is 1 and 3, etc., etc. All the numbers that you see on screen currently are prime numbers. There are even more of them. There are an infinite number, but you'll notice that the spacing between each of the prime numbers gets a little bit bigger and bigger each time. Pause the video for a sec, write down that definition so that you definitely know what it is, because you're going to need it for finding a prime factorization. So how then do we find the prime factorization of a number? What does that actually mean? It means that we are going to find what prime numbers multiply together to give us the number that we want. So for example, what prime numbers multiplied together will give us 48. In order to do this, we're going to first start just by thinking what two numbers multiply together to give us 48. Well, I don't know off the top of my head, but I know that it's an even number, so I can say at very least 2 and 24. If we multiply these together, that'll give us 48. I also know that 2 is a prime number, so I'm going to put a box around our 2, just to help me remember that it is in fact a prime number. 24 is not a prime number, it's a composite number. So we're going to do the same thing again. What times what gives us 24? Well, here I know that 6 times 4 would give us 24. You could also go for 8 times 3. Both of them are fine. It doesn't matter. You'll get the same thing in the end anyway. But we'll say that. 6 is a composite number, so is 4. So we don't get to box anything here. And then we do it again. What multiplies together to give us 6? Well, that would be 2 and 3. 2, we've already said, is a prime number. 3 is another prime number. We also have to do this to 4. 4 is going to be 2 times 2. So we have 2 more prime numbers. And at this point, all of the numbers that we have are prime, which means that we are done. You will notice if you look at this kind of upside down, it kind of looks like a tree. This thing that we've made here, we often call a factor tree. It is upside down, but that's fine. Don't worry about that. So, in terms of what our prime factorization is then, we're going to take all of our prime numbers, and we're just going to multiply them together. So we have 2 times 2 times 2 times 2, and then we have 1 times 3. And this thing is going to be our prime factorization. Every single number in here is a prime number, and if we multiply all these together, so we get 4 there, we'd get 8, we'd get 16, if we multiply that by 3, we get 48. If we multiply all these together, it should give us our original number. So this thing is the prime factorization. If you need to copy this down, which you should be doing, pause the video now so that you have this nice example of prime factorization. For our you-do for today, you're going to find the prime factorization of 36. As a bonus challenge, what would the prime factorization of 17 be? That's a little bit trickier. But try these problems, pause the video, do them in your spiral now. So some things to remember about prime factorization. First off, what is a prime number? It's a number whose factors are 1 and itself. We mentioned this earlier, a composite number is a number that is not a prime number. One important thing to note, as you see with Batman and Robin over there, prime numbers are not only odd numbers, because 2 is also a prime number. It's also not going to mean that every odd number is a prime number. 9 is an odd number, but it's actually a composite number because it's the same thing as 3 times 3. Anyway, to find the prime factorization of a number, find 2 factors of that number, and then just repeating that until you only have prime numbers. Prime factorization then is written as the product of all of those prime factors. We saw that in our example. Finally, this kind of goes into that bonus problem from the UDO. The prime factorization of a prime number is just that number. So for example, you're supposed to find the prime factorization of 17. Because 17 is a prime number, your prime factorization is just 17. There's nothing else you can do with it. It just stays like that. Pause the video in case you need to write any of these down. Suggested practice problems for this video: you're going to find the prime factorization of those 5 values. At least one of them is prime, so think about what we learned in the things to remember. And then, as a little bonus problem there, explain why the following thing of multiplication, the following expression, I should say, is or is not a prime factorization. Is it a prime factorization? Is it not? Why or why not? Explain it if you want. Other than that, good luck.